My name is Nazeer from the Faculty of Civil Engineering Technology. Welcome to all of you in Canada, and for those international viewers, welcome to you also. Nice to have you with us, all of you. When we look at what we're intending to do here, we are given a function and we are intending to find the equation of the tangent and normal line of that function at that point. Before we could actually find the equation of the tangent and normal line, we have to find the slope of the tangent and normal line. And when we look at this equation or this function that we have here, we see that we have division that's happening. So if we were to substitute -1 for x, we would have division by 0, which means that it is undefined. Really means that it has an asymptote at -1. And as we look at the graph of the function, we see that -1 is running right in here, and this graph comes infinitely close to -1 but never equals -1, and then it jumps across and it comes on that side. The point that we're asked to find the slope of the tangent line to, or the tangent line to this point, it is going to be 2, which is right there, and 3 up, which is right there. So that point is right there. This is the coordinate to that point right there. I've placed or superimposed a tangent line in here, right? Touches at one place and then it goes off. But because of this right hand side of that line is falling, it's going to be a minus slope. We are expecting that to be, when we work out the slope of the tangent line, it'll be a minus number. The normal line will go through that particular coordinate point and make a 90 degrees with that tangent line, so it is perpendicular, and that is going to be, if you put a normal line through that, you'll see the right hand side of that normal line is rising. It's going to be a positive slope. Okay, so keep that in mind as we go through this. The first thing that we're going to have to do is go and take the derivative of this function, and once we have the derivative of the function, derivative of the function, it's really the equation of the slope of the tangent line. Is not the equation of the tangent line, it is the equation of the slope of the tangent line. When we look at this, we have to take the derivative, so we have to prepare it first of all for taking the derivative. I'm going to take this binomial to the numerator, write it as an inverse, which is going to be a -1 power, and place it up there, and then I'll take the derivative of that. So let's go and prepare this function for that process. And we got rid of that, and again I've taken the denominator up to the numerator, write it as a reciprocal, and that's where we're at. We are now prepared to do the derivative of this function. The y becomes dy dx, rise over run, is equal to 3 times -1, and reduce the power by 1 will give you -2. And then we go and take the derivative of the inside, because this is chain rule, and we're going to have a 1 on the outside for that. Let's go and look at it. The y becomes dy dx. I'm going to multiply by -1 times 3. I'm going to reduce the power by 1, so -2, and then I go and take the derivative of the inside, which will give you 1. It doesn't change very much because it's 1, right? But you have to get into the habit of seeing that, because when it comes to other problem, you might just do the derivative of the outside and forget about the derivative of the inside. So when we look at this, this becomes, well, I'm going to take this down to the denominator again, write it as positive exponent. This multiplies out to be -3 times 1 will give you -3. Take this down to the denominator, write it as a reciprocal, change the power, and then we have that. The other step for us to get the slope of the tangent line is to substitute the 2 for x. The 2 of that point, the coordinate point, for x. And when we go and do that, this is what we have. We have the 2 in there, we have that. You could clearly see that this inside the bracket here is going to be 3 squared will give you 9. -3 divided by 9 will give you -1/3 is the slope of the tangent line. Like I mentioned already, we have to find the slope first, and then we have to go and find the tangent line after. But before we do that, I'm going to introduce another formula that gives us the slope of the normal line. Okay, so this formula here says you take the slope of the tangent line multiplied by the slope of the normal line, it'll get equal to 1, or minus 1, not 1, but minus 1. If I were to take this and divide it into that, I will get positive 3. So now I have the slope of the tangent line and the slope of the normal line. Here comes another formula, and this is called the point slope formula, right? It deals, the y1 and x1 are the coordinate points right here. So you have to have a point and you have to have a slope. Well, we have two slopes, right? So we're going to go and find the equation of the tangent line and normal line using the point slope formula. Okay, we have to substitute the appropriate slope there. The point will stay the same. When I substitute for y right there, y1, that'll become minus 1, right? And when I substitute for x1, this becomes minus 2. So keep that in mind. The formula itself has the minus in it, so you have to remember that it changes sign. And I'm going to substitute the obviously the appropriate slope. I'm going to go with the tangent line first. So I'm going to go and substitute y in there, minus 1. That's where it comes. And then 2 in 2 for the x value right there, and that becomes minus 2. Now I'm going to go and put this in general form, right, for the equation. General form means that you're going to have a positive x, everything else is going to be there equal to 0, no fraction. So for me to have no fraction, I have to multiply out this 3. So I'm going to multiply everything here by 3, and this will become 3y minus 3. This will become minus 1, so it'll be minus x plus 2. And that's what we have here. 3y minus 3 is equal to minus x plus 2. I'm going to go and put it in the standard general form, positive x, so I'm going to take this over to that side. It becomes positive. The y stays the same. I'm going to take the 2 over, it'll become minus 2, and it'll be minus 5. This is the equation of the tangent line. So we are almost there. We got to go and find the equation of the normal line now. And let's go and do that. The only thing that really changes from this form is that we're going to swap out the slope. So we could write this whole thing and then put 3 in for the slope, and then we would be good to go, and then follow through with that. Again, this is the equation that we're going to use. We have minus 1 already substituted and minus 2 already substituted. I'm going to put the 3 there for the normal line. And let's go and look at that. That's what it is. I'm going to multiply this out. This becomes plus 3x minus 6 right there. I'm going to go and put it in general form now. And the x is positive here. I'm going to take the y over to that side, minus y. Take this over to the other side, becomes plus again, minus 5. And the final form of this is going to be 3x minus y minus 5 is equal to 0. Okay, so that is how you get the tangent and normal line. And it's not so bad, but you have to do a couple of problems and get that firmly in your mind. Let's go and look at another problem here. We have this one now. Basically the same problem. The only thing, we have a fraction, and it's not going to make too much of a difference. When we look at the plot of this particular function, it looks like this. We're given a point on that curve, 3 and minus 6, right about there. I put an approximate tangent line in there. We see that the right hand side is rising, so we're expecting a positive slope. The normal line will go through that point. We see that the normal line, the right hand side of that line will be falling. We're expecting a negative slope. Okay, so let's go and find the derivative of this thing here. Let's go and prepare it first. And when we do that, this is what we have. We're going to go and take the 3, multiply the term, and reduce the power by 1. And then when we look at this particular term here, there's an understood 1 here on the x as the power, multiply and reduce it by 1, so it'll be 0 power. Anything raised to the 0 power is 1, so we are ending up with -5 right there. Okay, so you could quite see that multiply and divide by 3 will cancel out. This becomes really 1. Okay, let's go and substitute our 3 for the x and follow through with that. This becomes 1, this becomes 9 minus 5 will give you the slope of the tangent line is going to be +4. It was rising on the right hand side, so we are correct with that. Let's go and use the formula to get the slope of the normal line. And the formula states that if you want the normal line, you divide -1 by the slope of the tangent line, which will give you -1/4. Alright, so we have tangent line has a slope of 4 and normal line has -1/4. Let's go and use the point slope formula to get the general equation of both of these lines, the tangent and normal line. When we look at the point slope formula, we see that this would be the y value. Well, because this is minus, it'll become plus there. This will be the x value, it becomes minus right there. But we're going to use this formula with the slope of 4 and come up with the general equation for the tangent line. And here we go. We have, we're going to substitute the tangent line slope, which is 4. We see that this is 6, it becomes +6, or this is -6, becomes +6, and this will become -3 right there. We're going to multiply out this, it'll be 4x minus 12. And that's what we have here, 4x minus 12. I'm going to go and put it in general form. The x is positive here. I'm going to take the y over, I'm going to take the 6 over, and I'll come up with this guy here. Right? When I take positive 4x minus y minus 6 will give you -18 equal to 0. So we have the equation of the tangent line right there. Again, the only thing that changes from this particular equation that we have here, or this particular step, is we're going to swap out the slope to -1/4. And that's what we did right here. I'm going to multiply this whole thing by 4. So we'll have 4x plus 24 minus x plus 3. And that's what 4x plus 24 minus x plus 3. The x is negative here. I'm going to take it over to this side and make it positive. And then I have 4y. I'm going to take this over to the other side, it becomes negative plus 21. And that is equal to 0. That is your equation of your normal line. I hope that these two examples provide you with the tools that you need to deal with tangent and normal lines. If you like this video, please do give it a thumbs up and subscribe, and it lets me know that I'm not wasting my time. Have a great day. Nice to have you with me. Bye-bye.